specifically the manipulation of cue switching variables in children and adults. And so we're going to hop back to executive functions. And so as we heard this morning, cognitive flexibility includes the ability to adjust to new tasks and demands, and it is one of the last executive functions to develop, and it is also one of the more sophisticated. And so in this talk today, I'm referring to the broad term cognitive flexibility as maintaining task sets in mind and the ability to switch between several different roles and tasks on a trial-by-trial basis. Further, previous neuroimaging studies have shown brain activation and task switching networks still develops in adolescence. And finally, the maintenance of goals and task sets via working memory develops in early childhood and improves throughout adolescence. And so with all of this in mind, one of our motivations for this study was to see if we could push performance in children and adults using different manipulations and parameters to see if we could get them closer together. So essentially we wanted to see how far we could push task control networks. And so one of our first goals was to see if there are any clear developmental transitions in performance related to task switch manipulations. We wanted to see if there was any short-term learning involved within a session. And also, how does working memory interact with task switching performance over age? And so to do this, we created a new task design. And I'd like to just run through a quick example of what a trial looks like. And so the participants see this screen, and a trial begins when a task is cued by a red outline. And after a 500 millisecond delay, a target appears for 2 seconds, and this is when the participants would indicate their answer. And just to break it down for the underlying structure, let me see if I can. So we have the task indicator bar, and there are 4 different roles or tasks that can be cued during a trial. And so first we had shape, then inner color, then pattern, and outer color. And so we chose these just because there wasn't a lexical demand, it was easy for kids to do, and it was fun and colorful. So then there are the response choices, and there could either be 2 or 4. And these choices mapped onto a little button box controller that the kids used, and the adults. And then there's the target. So we instructed all the participants to match the target to one of the response choices based on the current role. And in just a little bit more detail, we had 9 runs of increasing difficulty over about 45 minutes, and we manipulated response choice consistency. And just to show you what that means, some levels, these response choices remain constant throughout the whole level, and in other ones, they would switch from trial to trial, which we anticipated would be more difficult. We also varied the number of possible cued tasks. So we started out with 2, just shape and inner color, then we added a third pattern, and a fourth of outer color. And we also varied the number of possible responses. We saw an example with both 2 and 4. Oh, God. Sorry. And runs 1 and 10 were identical in difficulty level, and that was in order to quantify short-term learning. Oh, thank you. I have a little cold. Oh, God. Sorry. Much better. Okay. So runs 1 and 10 were identical in that they both had the same number of trials. They both only had 2 possible rules, so shape and color, inner color, and they only had 2 response choices. And the only difference being that we used 2 different stimuli lists within a subject from levels 1 to 10. I'm so sorry. So we collected data from 60 children and 60 adults, and we had a very wide age range of about 10 years for both age groups. And so in reference to our first question, I'm so sorry. Are there any developmental transitions in performance related to task switch manipulations? And before we can answer that question, I just want to take a step back and zoom out and look at performance differences overall between adults and children. And so here we have mean accuracy across all the levels 1 through 9. And adults are fairly consistent throughout the entire experiment, which was really surprising. Remember, we added a third rule and a fourth rule. We varied the mapping or the choice response consistencies between levels, and we added 4 responses at level 7. And adults, it seems their task control systems just cannot be pushed. They're really resilient, at least to the parameters we chose. Children are also fairly consistent in the early levels, but they do show a performance degradation when we switch to 4 response choices. And in terms of mean response time, adults are, again, really consistent, and they show a little bit of a hit in the later levels. And similarly in children, they follow an eerily similar pattern to the adults. We can't really say why, but it's wonderful. Again, with the later levels being more difficult. Excuse me. I'm so sorry. Okay. So the performance transition. So here's again the overall adult accuracy between levels 1 through 9 in the black. And what we did here is we binned the child age group by their age, and the number in parentheses indicates how many children were of each age. And so when we look at the youngest children, ages 8 and 9, we see that they perform significantly worse than adults, and they suffer a critical hit in accuracy at the later levels. Intermediately aged children, ages 10, 11, and 12, perform slightly better with a little less of a hit at the later levels. And finally, older children, ages 13, 14, and 15, perform significantly better than their younger peers and are also more consistent throughout all the levels. In terms of response time, across all the levels, there's the adult performance, just for reference. And the younger children, again, perform among the slowest. Intermediately aged children are a little faster. And the older children, again, are hovering around adult levels of performance. And so, do we see any short-term learning within a session? Indeed, we do. So, children improved by about 3% from levels 1 to 10 in terms of mean accuracy. And level 10, again, is the identical level to level 1, but at the end of the session. And adults improved significantly by 2.5%. And again, in response time, both children and adults improved from the beginning to the end of the study. And I'd like to just point out here that child ending performance is very similar to initial adult response times. And so I just wanted to break this down again by the child age bins. So this is again mean accuracy from levels 1 to 10. With older children up here by adult performance. And it seems like in general most age groups do show improvement, at least short term, between levels 1 and 10. And again, in response time, most of the age groups improve, except for this guy. And third, how does working memory interact with task switching performance over age? And so to do this, we conducted a follow-up study where we added a working memory manipulation, and we collected data from 47 children and 48 adults, again with a really wide age range. And so just to show you really quickly, the task is very similar, and it begins with a task cued in the red. And then during this time, the subjects have to remember the task and the properties of all these stimuli. Oh, thank you. Oh, I'm okay. So they have to remember all these properties because when the target appears, it's alone, and so they have to really recruit those working memory networks. And this proved to be a little difficult for the younger children, but they did it. Okay, so just to orientate you again, here's mean accuracy across all the levels for the original study of the data I just showed you, and we call this lower demand. And then when we look at the higher demand study, adults are, again, really consistent in the beginning. and they have even more flat performance than the lower demand study, but they show a similar pattern and performance degradation as the children did in terms of the later levels. In response time, here's that eerie pattern again, and even eerier, it happens again, with children performing significantly slower and adults also kind of hovering around child levels in that lower demand task. And the improvement within the higher demand task with the original accuracy for levels 1 to 10 and the lower demand. Children, oh no, that's okay. So children improved in the higher demand task by almost 8%, and then the adults improved by almost 5%. And so that's just for the original. So they improved significantly more once we added that higher demand of working memory. And similarly with response times, adults and children significantly, they perform significantly worse. And again, ending child performance in level 10 is very similar to initial adult response times. And so while we were able to match and kind of push performance of children closer to that of adults, we were more interested in how child performance transitions from child levels to adult levels over development. And so in conclusion, just to wrap things up, age-related improvements in reaction time were gradual, but a shift in accuracy was observed around 18 years. Increasing working memory demand affected accuracy only at the hardest levels, while response times were slower for all levels. And we saw similar rates of short-term performance improvement in both age groups and more improvement in the working memory demand, with higher working memory demand, excuse me. And with practice, child performance was similar to adult initial response times. And so just to end with some current and future lab directions, we want to apply both the working memory manipulation and the original study to an imaging study, investigating how short-term learning as seen within the study maps onto slower age-related changes between individuals. And I'm also particularly interested in examining how trajectories of adaptive control differ in atypical populations, including those with ADHD, OCD, and Tourette syndrome. And I'd like to thank my lab, and thank you for your attention.
For one question.
Oh, sorry.
I'll ask one, and that's this, I was wondering if you could comment on the individual difference variability. I mean, you presented everything kind of as groups, but were your error bars standard errors or standard deviations?
Standard errors.
So I'm just curious, did you see much individual difference variability on your tasks within, your kids and your adults, your overlap, and those seem interesting?
I mean, the younger children especially were very widely variable. So let's see. Oh gosh, that's not working. Okay, forget that. I can't really say with our sample size, the children were so young and it's just a behavioral study, so I'm not sure if we can say anything about that. Yes? Yes.
The way you designed your task, are you able to look at trials where they're repeating the same task versus switching?
Yes.
And did you look at, say, switch costs or mixing costs as they change as they go through personal development?
I can't really see the other slides. Yes, we did. We also had many more overall manipulations, so they were kind of confounded with, we had an overall congruency condition manipulation where we either had 0, 50, or 20% of the time where the target would be an exact match to the response choice. And so in the 50% condition, we didn't see any switch costs really overall across all levels within a group average. So in our new study that we're piloting right now, we have only 0%, so none of the targets exactly match. So I think there we'll be able to we'll be able to answer that question.
Okay, we're going to have to move on to our last speaker, Carter Wendell.